So today's lesson, we're going to look at page 56 in the notebook, which is the Pythagorean Theorem's Converse. So just to start, we're going to go over a review of the Triangle Inequality Theorem. So remember that when we talked about triangles, we reviewed that the sum of the two shortest sides must be greater than the longest side. So we're always going to make the longest side C when we're thinking about this, and then we're going to add A and B. So remember that the way that the Triangle Inequality Theorem works is that it must be greater than the longest side. So A plus B must be greater than C, which is what creates a triangle. If A plus B is less than or equal to C, then it's not a triangle. So if I'm looking at these values and determining whether or not something forms a triangle, I'm checking, does A plus B turn out to be greater than C? If it does, then it's a triangle. If it does not, then it's not a triangle. So remember that the largest number is C. So in this one, the largest number is 9. So we're going to put 9 by itself. So that's our value for C. And then the other two sides are A and B. Since I'm adding them, it doesn't really matter. So I'm comparing 3 plus 6. And I want to see what relationship that has with 9. And so if I add 3 plus 6, that's 9. And so that means that these two things are equal. So when it's equal, that means that no, it cannot form a triangle. Okay, so I'm going to do that with each set of numbers. So the largest number is what we're going to call C. So 7, 4, and 5. 7 is the largest number, so we're going to put 7 by itself. We want to see how that relates or compares to the sum of the other two numbers, which are 4 and 5. So if I find the sum of 4 and 5, that gives me 9, and I want to compare 9 to 7, and 9 is greater than 7, and so that means that this one does form a triangle. Okay, so the sides 7, 4, and 5 will create a triangle. And then our last example, we have 2, 3, and 8. 8 is the largest number, so that's what we're going to identify as the value for C. So we're going to place 8 by itself. And then we have 2 and 3 as the other side, so we're going to add those two together. And we want to be able to compare that sum to the number 8. So we're determining, is it greater than, less than, or equal to? So 2 plus 3 is 5. 5 is smaller than 8. So that means this is less than. So since 5 is less than 8, no, these cannot form a triangle. So that sum has to be greater than that third side. So just kind of a reminder of how that triangle inequality theorem works, because the converse of the Pythagorean theorem is similar. So what we know from the Pythagorean theorem is that if I have a right triangle, then the sum of the squares of the legs of the triangle is equal to the square of the hypotenuse. So if we think about just the Pythagorean theorem, right, the Pythagorean theorem tells us that A squared plus B squared equals C squared. So if a triangle is a right triangle, C squared has to be equal to A squared plus B squared. What the converse states is that if A squared plus B squared equals C squared, then we have a right triangle. So in these pictures, in these problems, we don't have pictures of a right triangle. We just have numbers. So we're determining, is this a right triangle or a different type of triangle? We can actually classify all three types of triangles by angle here. So a right triangle is when C squared is equal to A squared plus B squared. An obtuse triangle actually occurs when C squared is greater than A squared plus B squared. And an acute triangle occurs when C squared is less than A squared plus B squared. So the hint was to always put C squared on the left, because if you think about an obtuse angle is a bigger angle, so that inequality faces the C squared, it's larger. That kind of gives you a clue that we're talking about obtuse. And then if C squared is smaller, right, the inequality gives you a clue that it's an acute triangle. So what we're going to do for each of these problems is identify C and then square everything and find the sum. So what we're looking at here is we want to look at the numbers and identify which one we're going to call C. And so in this case, C is 27. And so we're going to do 27 squared, and we're comparing that to 11 squared plus 25 squared. Okay, so when we're doing these, we're still doing a comparison like we did with triangle inequality, but we have 3 different possible answers. In addition, we're squaring each piece, whereas in triangle inequality, we just took the sides to determine if it's a triangle. So these, we know they're a triangle, we're classifying. So if I square 27, that's 729. And if I square 11, that's 121, plus 25 squared is 625. So I'm comparing 729 with 121 plus 625 is 746. So the 746 is larger. So when C squared is smaller, that's going to create an acute triangle. Okay, so again, if C squared is smaller, my answer is that that forms an acute triangle. So we're just going to go through and do the same process with each of these sets of 3 numbers. So we're first identifying what the largest number is, and that's the one that's going to be first. So we have 22 squared. And we're going to compare that to the square of the other 2 numbers added together. So 11 squared plus 17 squared. If we square the number 22, that's 484. And then we have another 11 squared, so 121 plus 17 squared is 289. So we're comparing 484 with the sum of those 2 numbers, which is 410. And so the larger number is on the left, so 484 is greater than 410. So that means that this creates an obtuse triangle. For the next one, we have 12, 19, and 22. So our C is 22, so 22 squared. We're going to compare that to 12 squared plus 19 squared. Okay, so we've got 22 squared compared to 12 squared plus 19 squared. 22 squared, again, is 484. We're comparing that to 144. Plus 19 squared is 361. So 484 compared to the sum of these is 505. So 505 is larger. So that means that since the C squared is smaller, this is going to form an acute triangle. For the remaining problems, notice that we now have radicals involved in them. And so we're still going to do the same thing where we need to figure out which value is C. If you need to, if you can't tell which one's larger in terms of if one has a radical and others don't, you can always calculate that value. So if I multiply 5 times the square root of 2, that's about 7.07. And so that means that 5 radical 2 is going to be the C. I'm not going to use 7.07 though. I'm going to use 5 radical 2. So I'm squaring 5 radical 2. And then I'm adding the other 2 numbers squared and summed. So 5 squared plus 5 squared. Remember that when I'm squaring a product, I'm squaring both pieces. So this is like I have 5 radical 2 times 5 radical 2. And so I can multiply the piece in the radical together and the piece outside of the radical together. So 5 times 5 is 5. And then radical 2 times radical 2 is radical 4, which is just the number 2. So that means that 5 radical 2 squared is actually, oh, sorry, it's not 10. It is 5 times 5, I said was 5, but that's 25 times radical 2 times radical 2 is radical 4. That number is 2. So it's not 10, it's 25 times 2, which is 50. If we think about squaring, 5 squared is 25, plus 5 squared is another 25. And so 25 plus 25 is 50. Since we came up with the same number that's equal, that means that this forms a right triangle. For the next one, we have everything in a radical. So I hope that you don't need to use a calculator to figure out which one is the largest. So if I have radical 3, radical 4, and radical 5, the one with the bigger radicand is going to be the bigger number. So that means that C is the square root of 5 for this one. And so I'm going to do the square root of 5 squared compared to the square root of 3 squared plus the square root of 4 squared. And so remember that when I square a square root, those things just cancel out and I get the number inside the radical. So the square root of 5 squared is just 5. The square root of 3 squared is just 3. And the square root of 4 squared is just 4. So I'm comparing the number 5 to the number 7. And so since 5 is less than 7, that's going to give us an acute triangle. And then our last problem for this lesson has another square root compared to values without a square root. So if you calculate 5 times the square root of 3, that's about 8.6. So that means that our C is 10 because 10 is the largest number. So we're going to do 10 squared, and we're going to compare that to 5 squared plus 5 radical 3 squared. So 10 squared is 100. 5 squared is 25. Remember what we did with the 5 radical 3? Essentially, we're squaring 5, and so that gives us 25. And then we're squaring the square root of 3, which is just 3. So 5 radical 3 becomes 25 times the square root of, times 3, which is 25 plus 75, which also gives us 100. So the C squared is 100, A squared plus B squared is 100. And so since those two things are equal, that means that we have a right triangle that we're working with. So again, remember that we're really just using this to determine what our answer is. So if we get an equal sign, it's right. If we get greater than, it's obtuse. If we get less than, it's acute. So you're using the converse of the Pythagorean theorem to determine what type of triangle you have.